So let's start with number 36. It says that a veterinarian depreciates an x-ray machine. He estimates the resale value is 90% of the value from the previous year, so we can approximate it with that. Find the resale value after 4 years. So here we're just going to plug 4 into the function. So V of 4 is equal to 10,000 times 0.9 raised to the 4th power. And that I can plug into my calculator. And that gives me $6,561. If the veterinarian wants to sell his practice 8 years after the x-ray machine was purchased, how much is the machine worth? So that's just V of 8. So that's, it says round to the nearest $100. I got $4,304, so I'll write $4,300. Write the logarithmic equation in exponential form. And so we have log base b of x equals y, and that translates to the base is b, so b to the y equals x. So I can just rewrite it. And remember, a natural log is equal to log base e. Okay. And so we have log base 5 of 125, so this translates into 5 to the 3rd equals 125. And remember, natural log is base e, so that means e cubed equals x plus 4. This one is k to the m equals r. Write the exponential equations in logarithmic form. So the base here is 2, so it's going to be log base 2 of 16 is equal to the power, which is 4. And here, log base 1/2 of 32 is equal to the power, which is minus 5. Log base a of b is equal to the power, which is 9. Evaluate the following logarithmic expressions without a calculator. Show all work. So this is asking, what is the power that I need to raise 2 to get 64? Well, I know 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. So the answer is 6. And we'll write because 2 to the 6th is equal to 64. This one says, what power do I need to raise 3 to get 1/9? And I'll just write that this is equal to log base 3 of 1 over 3 squared. So the answer is -2, because 3 to the minus 2 is equal to 1/9. Log base 10 of 10,000. So we want to find the power that I need to raise 10 to get 10,000. So if we do 10 to the 3rd, that's 1,000. 10 to the 4th is 10,000. So the correct answer here is 4. And we'll just write because 10 to the 4th is equal to 10,000. Simplify the following expressions. So 2 raised to what power? This is the power that I need to raise 2 to get x minus y. So if I raise 2 to that power, I'm going to get x minus y. Okay, and I'm going to write these out as properties of logarithms. So if I have b raised to the log base b of x is equal to x, and log base b of b to the x is equal to x. Okay, so log base 7 of 7 to the 13th, that's going to be equal to 13. And these two together tell me that log base b and b to the x are inverse functions of one another. So you see, if I compose them with one another, I get the function x out. And if you remember, that's what it means to be an inverse function of one another. Natural log of e to the x squared plus 2 is going to be x squared plus 2. The natural log and e undo one another. Log base p of p is equal to 1. And the natural log of 1 is 0 because e to the 0 equals 1. So that tells me the power that I need to raise e to get 1. Identify the shifts from the parent function. F of x equals log base 2 of x to the graph of that one. So this one is going to be shifted to the left by 5, and this is shifted down 2. And so if I start with the parent function, log base 2 of x, so log base 2 of x goes through the point 1, 0, and then it also goes through the point 2, 1, because the base is 2. So it looks like that. And so I want to shift it to the left 5. So I'm going to go 1, 2, 3, 4, 5. So this point here goes here, and then the asymptote goes here at -6, or at -5. And then if I shift over 1 from that and up, I get that point. So there I have shifted it up left 5, and then I want to shift it down 2 units. So we're going to shift the whole thing down 2 units. This asymptote stays the same, but this is shifted down 2 units. This point is shifted down 2 units. So it looks like this. Okay. Next page. Okay, apply the product, quotient, and power properties of logarithms and simplify if possible. Okay, so let's write those properties down. So log base b of a times b is equal to log base b of a plus log base b of b. Log base b of a to the k is equal to k times the log base b of a, and log base b of a over b is equal to log base b of a minus log base b of b. Okay, so let's use those properties. Okay, so this is equal to log base 4 of x to the what power? Well, the x to the 5th, and then I have also a 1/7, so it's x to the 5/7. So I can use this power property to pull that 5/7 out front. So 5/7 times the log base 4 of x. Okay, this one I can use the quotient property. So I have log base 10 of m squared plus n minus log base 10 of 100. Now I can simplify log base 10 of 100 because 10 to the 2nd power equals 100. So that becomes 2. So log base 10 of m squared plus n minus 2. This one I can split up because I guess that is inside. It's kind of ambiguous there because there aren't parentheses, but anyway, so we can assume that that's what that means. And so I have log base 7 of 49 plus log base 7 of k. Now remember, 7 squared is 49, so that thing simplifies to 2. So 2 plus log base 7 of k. Write the logarithm as a sum or difference of logarithms. Simplify each term. So I'm going to write this as powers here. So I can take the 1/4 completely out. So 1/4 natural log of x squared plus 4 over e cubed. So that's 1/4 times, and I have a quotient here. So natural log of x squared plus 4 minus natural log of e cubed. And I can simplify natural log of e cubed further. So I get 1/4 times the natural log of x squared plus 4 minus, and I'll just go ahead and distribute that 1/4. So it's going to be 1/4 times 3. So that's 3/4. Write the logarithmic expression as a single logarithm with coefficient 1. Okay, so I can start by taking any coefficients out front up as powers. So log base 6 of r to the 4th minus log base 6 of s cubed minus log base 6 of t squared. And so then I get equals log base 6 of, well, the r to the 4th is going to be on the top. And since the s cubed and t squared are both being subtracted, those are going to go on the bottom. So there it is written as a single log with coefficient 1. Number 45, the variable pH in the formula represents the level of acidity or alkalinity of the liquid, and H is the concentration of hydronium ions in the solution. Determine the pH of the following. Okay, so I'm looking for this, so I'm given this formula. That's what I want to use. So I want to determine the pH of a tomato with the following. Okay, so the pH will be equal to negative log of 6.31 times 10 to the minus 5. So I'm just going to plug that into my calculator. So negative log of 6.31 times 10 raised to the negative 5. And I'm going to put the negative 5 in parentheses. I got 4 point, what does it say to round? It doesn't say what to round to. I guess I'll just round 4.19990. Maybe I just round that to 4.2. Okay. Next, I want to determine the pH. So the pH of the second one is going to be negative log of 3.16 times 10 to the minus 11. So I can type that in as well. 3.16 times 10 to the minus 11. And that gives me 10.5. Okay. Determine the hydrogen concentration of hydronium ions of the following. An onion with a pH of 5.6. So we'll set 5.6 equal to the pH. That needs to equal negative log of that H plus. So so I can multiply both sides by -1, and I can take both sides as powers of 10. So I get 10 to the negative 5.6 is equal to H plus. Okay, so I can take that power, 10 raised to the negative 5.6, and that gives me 2.511. And then my calculator has this capital E minus 6, and that's the way it does scientific notation. So that's times 10 to the minus 6. That's what that capital E means in my calculator. Okay, the next one I'm going to do over here. So for the baking soda, the pH is 8.4. Negative log of the H plus. So I can multiply both sides by -1 and take both sides to the power 10. So I get 10 to the negative 8.4 is equal to my H plus. So my H plus is equal to, when I type that in, 10 raised to the negative 8.4. I get 3.98 times 10 to the negative 9. Given that log base b of 2 is approximately 0.356 and log base b of 3 is approximately that, approximate the value of log base b of 24. So log base b of 24 Well, I can break 24 up into its factors. So log base b of 20, so 24 is equal to 2 cubed times 3. So I can use my properties. So I have log base b of 2 cubed plus log base b of 3. So that gives me 3 log base b of 2 plus log base b of 3. So that gives me 3 times, what was log base b of 2? It's about 0.356 plus log base b of 3 is about 0.565. So I can plug that into my calculator. 0.356 plus 0.565. 1.633. So that's an approximation. Use the change of base formula to evaluate log base 6 of 23 using base 10 or base e. So I'll write them out using both so that you can kind of choose. So let's just go down here. So we can say log base 6 of 23 is equal to log base 10 of 23 over log base 10 of 6. Or I could write natural log of 23 over natural log of 6. Either way. So if I plug that into my calculator, that gives me 1.7499. So like that. Okay. Number 48. It says solve the following exponential equations. Give the exact solution and an approximation to 4 decimal places. Okay. So for this one, I want to start by, I can take the natural log of both sides. So the natural log of 5 to the 3x minus 2 is equal to the natural log of 625. Now the reason I knew I needed to take the natural log is because I can see that the thing I'm trying to solve for is up in the exponent. So that's the case with all of these. That's why they're called exponential equations, because the x is in the exponent. That is how we know that we need to use natural logs or logarithms to solve these kinds of equations. So by the power rule, that 3x minus 2 is going to come down. Oops, sorry, I'm still on the highlighter. 3x minus 2, natural log 5 minus natural log, or equals natural log of 625. Okay, and then I can distribute this out. So I get 3x natural log 5 minus 2 natural log 5 equals natural log of 625. And then I can, I'm trying to solve for this x right here. So I want to add the 2 natural log 5 over to the other side. So I get 3x natural log 5 is equal to natural log of 625 plus 2 natural log 5. I can combine those two into 1. So I get 3x natural log 5 is equal to natural log of, I want to do 625 times 5 squared. That gives me 15,625. And then I get x is equal to natural log of 15,625 divided by 3 natural log 5. And I can't simplify that any further, but I can plug it into my calculator and get a decimal approximation. So if I do natural log of 15,625 divided by, I'm going to open parentheses, 3 natural log of 5, that gives me 2. So the answer to part A is 2. Part B, another way to get that 2, I'll just real quick give you another way. Another way to get that 2 is to notice that 625 is actually a power of 5. So, so if you do 5 to the 4th, I think, yeah, 5 to the 4th is 625. So we get 5 to the 3x minus 2 is equal to 5 to the 4th power. So then I can just set 3x minus 2 equals 4, and I can solve it that way. 3x equals 4 plus 2, which is 6, and x equals 2. So that's another way to solve that one. Okay, so for this one, I have 6, let me erase that. Okay, so for the next one, I have 6 to the 2x minus 5. I can go ahead and add that 8 over, equals 20. Now, I don't even have anything close to the same base here, so I am going to have to use logarithms on this one. So I can say, I can take the natural log of both sides, and I get 2x minus 5 times the natural log of 6 is equal to the natural log of 20. Then I can distribute 2x natural log 6 minus 5 natural log 6 equals natural log 20. So then I get 2x natural log 6 is equal to natural log 20 plus 5 natural log 6. And then I can divide everything over. I get x is equal to natural log 20 plus 5 natural log 6 divided by 2 natural log 6. And I can plug that into my calculator. When I type that in, I get that that's approximately 3.33597, so 3.3360. So that was part B. I'm now on to part C. Okay, and so I can take the natural log of both sides. So I have 4 to the x plus 2 equals 6 to the 3x minus 4. I could take the natural log of both sides, and I get x plus 2 times the natural log of 4 equals 3x minus 4 times the natural log of 6. And I can distribute. So I get x natural log 4 plus 2 natural log 4 is equal to 3x natural log 6 minus 4 natural log 6. Now I want to solve for the x. So I'm going to highlight the terms that have x in it. I want to add and subtract to get those on one side, and add and subtract to get the ones that don't have x onto the other side. So I have x natural log 4 minus 3x natural log 6 is equal to negative 4 natural log 6 minus 2 natural log 4. And so then I can factor the x out. Natural log 4 minus 3 natural log 6 equals negative 4 natural log 6 minus 2 natural log 4. And I can divide that over. So you can just leave it like that, or we can get a decimal approximation. Negative 4 natural log 6 minus 2 natural log 4. And when we type this into my calculator, I need to make sure we have parentheses around the top and bottom. Divided by natural log 4 minus 3 natural log 6. And so I got 2 2.49176, so 2.4918. Okay, the last one. We can notice on the last one that it looks a little bit like a quadratic. Okay, so the last one will give me e to the x squared plus 2e to the x minus 24 equals 0. So I can factor that. I get e to the x, and let's see, to get 24, I can use 4 and 6. So I want the 6 to be positive and the 4 to be negative to give me a positive 2 in the middle. So I get e to the x is equal to -6 and e to the x is equal to 4. Now this one I can throw out because I know e to the x is never negative. It looks like this, right? So there are no values of x that can give me e to the x equal a negative number. But I can use this one here. So I can take the natural log of both sides. So the natural log of e to the x equals the natural log of 4. This just simplifies to x. And I can do a decimal approximation of that. And it's 1.3862.